Hey guys, we're getting ready to jump into lesson 1.7, which will cover properties of exponents. This video is going to make some of those evaluating problems that had some exponents in them make a little bit more sense and maybe make them a little bit easier. It's also going to be really important as we move into some of the units further down the road where we're going to have some quadratic and exponential functions. Just a little warning for you. I am at my house. The kids are supposed to be asleep, so that means for sure you're going to hear some little kids' toys in the background. So just ignore that and let's focus on the math. Thanks. So in lesson 1.7, as I said before, we're going to be talking about properties of exponents. Our learning target for this lesson is that I can use properties of exponents to simplify algebraic expressions. So we've translated expressions, we've evaluated, and now we're going to start simplifying them. So taking more complicated expressions, kind of boiling them down to their simplest form. I do want to remind you guys that as you're going through the video, if you have any questions, make sure you're writing those over here in the margins so that when Mr. Thomas Wick or I come around to talk to you, we can see what it is you're confused about. All right, so before we jump into our notes, I want to give you a quick refresher of something from middle school. When you see something that looks like this, the large value that's the bottom of the exponent term is called the base. That is the thing that's going to get multiplied over and over again. The smaller number that's raised to the top is your actual exponent. That's telling you how many times you are going to multiply this value. So if I were to expand x to the 6th power, it would be x times x times x times x times x times x 6 times. 1, 2, 3, 4, 5, 6. Okay? Likewise, if you see something that looks like this and you want to make it simpler and save yourself some space on your paper, then count how many. Say there's 1, 2, 3, 4, 5, 6 x's and translate that back into its exponential form. All right, so let's go ahead and talk about some of the more complicated properties. First of all, I want to talk about an exponent of 1. If you have any value raised to the 1st power, that's just going to give you that same number back again. And that's because if you think about what I said before, your exponent tells you how many times you're multiplying something. Well, if I have 6 to the 1st power, that means I'm only multiplying 6 one time. So that's just going to equal 6. Right? Something that's a little bit stranger is 0 power. If something to the 1st power is 6, if I take away one of those 6's, what I'm left with is 1. So anything to the 0 power is going to be 1. It doesn't matter what kind of crazy complicated thing you have here. It could be an irrational value like pi. If I raise that to the 0 power, I'm getting 1. It could be a variable. It could be a decimal, a fraction. It doesn't matter. Anything raised to the 0 power is 1. Right? The next one we're going to talk about is product of powers. Product of powers is when you have two exponents with the same base. It's very important that you have the same base. If it's the same base, then all you have to do to combine those two is add your exponents as shown here. So what that would look like is if you had x to the 3rd power times x to the 2nd power. Well, for me to show you what this is going to look like or why this property works the way it does, I'm going to expand these as I did earlier in the problem. So x to the 3rd power, if I expand that, that's x times x times x. I'm going to switch over to another color so you can see where I switch to my x squared. If I multiply that by x squared, that means I'm going to have another x and another x, just 2, because I've got x to the 2nd power. Well, what I now have, if I want to combine all these x's, is I have 1, 2, 3, 4, 5 x's, which gives me x to the 5th power, which is why I can just take those two exponents and add them together and jump straight to this part. Okay, something that's a little bit harder for me to show you is the power of a power. This is where instead of just multiplying 2, you actually have an exponent term that's being raised to another exponent. So in an actual problem, it would look something like this. You might have x to the 3rd power and it's being raised to the 2nd power. Well, if I try to start expanding that, I'm going to first deal with the fact that this x to the 3rd power is being squared. That means that I have x to the third power times another x to the third power, because this is the base of this exponent. So that base is going to be multiplied 2 times. Now I'm to a product of powers. I can say, okay, there's 3 x's, there's another 3 x's, so I'm going to add that together and get x to the 6th. Well, that is the same thing as saying 2 times 3, and it'll work that way every single time. Okay? Now, power of a product is when you have multiple things as the base. If you have a product or 2 things being multiplied together as the base of your exponent, it's basically like your distributive property. You're going to take this m and multiply it into your base. The reason for that is, remember up here, there's always an understood little 1 as your exponent. Just like when you're looking at variables and you know there's that coefficient of 1 on the outside, there's always an understood exponent of 1 here. So all I'm going to do is I've got a little exponent of 1 here and a little exponent of 1 here. So now I'm really just using my power of a power rule. I'm taking that m, multiplying it by 1 and multiplying it by 1, and that puts the m as the exponent on both of those values. This comes in handy when you have something like 2x to the third power. Well, I can take 2 to the third power and I can get a number for that. I can't really do that with x. So if I just remember that there's a little understood 1 on each of those, then I can distribute that exponent of 3 and I end up with 2 to the third power and then x to the third power. And then I can actually say 2 times 2 times 2 and get a nice pretty number and have x to the third power. And you could also show that that works by saying 2, let's give myself, I'll come right here, by saying 2x times 2x times 2x, because that would be this base exponent multiplied 3 times. Well, 2 times 2 times 2, 2 times 2 is 4, times 2 is 8, and then I have x times x times x, which is x cubed. Okay, so you can kind of see that from 2 different ways. Negative exponents. Anytime you've got a term and you are trying to simplify it, we don't like leaving negative exponents. What a negative exponent is telling you is that your exponent is in the wrong location for the fraction bar. So what that means is you just need to flip it to the other side of the fraction bar. So if I had 2 to the negative 3 power, what that would actually mean is you would have 1 over 2 to the third. And then you could figure out what 2 to the third is. We already said it was 8. It also works the other way. If you had something, let me switch to another color. If you had something like 1 over, or let's say x over y to the negative 7 power. Well, that negative 7 power is telling you that it's in the wrong location. So you would need to bring that up to the top of your x, or to the top of that fraction. So what you would be left with, I'm going to have to erase this, it's in my way. What you would be left with then is x times y to the positive 7 power, and that would be your answer. You're never going to leave an algebraic expression with a negative exponent. You're always going to flip it to the other side. If that means creating a fraction and moving it to the denominator, then do that. If that means getting rid of a fraction and taking it up into the numerator, then do that. Quotient of powers is kind of the opposite of the product of powers. If you add the exponents when multiplying, then it only makes sense that if you're dividing and the base is the same, then you subtract, because those are just inverses. To show you an example of that, let's say we had x to the 5th over x to the 3rd. Well, let's expand both of those. So x to the 5th would be x multiplied 5 times over x to the 3rd, which would be 3 times. And then we would do what we've kind of been doing with our unit analysis. We would cross out things that divide to be 1. So x over x, that goes to be 1, so that's gone. X over x, that goes, and that goes. And what's left is just two x's, which would be x squared. Notice that 5 minus 3 is 2. Okay? Power of a quotient is exactly the same as our power of a power. You're going to remember that there's a 1 exponent on each of these. So you're going to distribute that m to each piece of that fraction. So you end up with a to the m and b to the m. To show you an example, you would have, let's say, x over 2, and I'm going to raise that to the third power. Well, if I was going to expand this, then the base of this exponent term is x over 2. So I'm going to say x over 2 3 times, because my exponent was 3. And now I've got fractions, so I'm going to multiply straight across my numerator. X times x times x is x to the third. 2 times 2 times 2 is 2 to the third, or 8. So all I've done is taken that. I should write that out for you. And you should write it in your notes as well so you can see that. That should be 2 to the third, which you can then continue on to be x to the third over 8. But it's important that you see that step, because that means all I've done is I've distributed that little 3 and said, okay, now x is raised to the third and 2 is raised to the third. All right, so make sure you keep these notes open as you get started on your practice, and let us know if you have any questions.